Today we're going to talk about something that most of you already know, all right? But I have to do this. We're going to talk about. We're going to talk about. Hang on one second. I'm going to introduce the concept of solving equations. And my guess is everybody's done that already. I know you did a little bit with Nate, but he didn't go far enough. And I have to go the whole way. We have to understand it. I have to make sure that everybody's on the same page. It's not going to take long. But we're going to do something fun today. It's going to be really cool. It's probably a way you've never thought of, exactly the way I'm going to show you today for solving equations. What is an equation? Yes, Mira? A problem. Okay, that's more. Okay, one side is equal to the other side.
It's a mathematical problem where you've got an equal sign and some form of, I can't think of the word, but multiplication, division, subtraction,
Right.
addition, etc.
Right.
And one side of the equal sign is the essentially equal to the other side.
Right. Right. Exactly. So I'm hearing that everybody's talking about equals, right? Why would they call it an equation if it has to have an equal sign? Oh, the word equal is basically in there, right? Oh, that's brilliant. Oh my God, that's fabulous. I never even thought of that before. So yeah, an equation has to have an equal sign, right? What is an equal sign?
It's
Okay, Ben.
two lines together.
It's two lines. Okay, it's two lines. There's an equal sign. What else is well, tell me more about an equal sign. Michael, you said something. I missed it. Oh no, you didn't. Somebody else did that. Gideon.
It looks like two subtraction signs.
Okay, but what is it? What is a equal sign? What does it mean?
It's saying that something is the same as something else.
Do you guys agree with that? So if you have something on this side, and then you have an equal sign, and then you have something on this side, you're saying this is the same as this?
Yeah. Supposed to be.
Come on. 1/2 is equal to 2/4. Come on, how can you possibly? That is not the same thing, or is it? Oh, it is. So whatever's on this side is exactly the same thing as on this side, in terms of value. It may not look the same, but in terms of its value, it's going to be exactly the same. Right, Mira?
Couldn't it not be the same for like in proportions?
Well, no, proportions are actually, the whole idea of proportions is that you are making them the same. You know what I'm saying? There could be, I could have written 3/4 here, and I can do that, I can write that, but it's wrong. You know what I mean? Because this does not equal this. See what I mean? So we violated that. So I am going to get out a little tool here for a second. I would have liked to have more time for this. Why on earth would I be bringing out? Lovely. We're going to lower that. Maybe that'll work. So we have a scale here, right? I'll put it right there like that. That's easier. Get it centered. Why on earth would I be bringing out a scale when we're talking about equations and equal signs? Andrea.
To describe balance among the numbers or
Balance. Okay, what were you going to say, Cassie?
Oh, I was going to say that each side has to be balanced like equal.
Okay.
Same.
All right. Okay. So that's pretty interesting. So I would agree with you. So I'm going to start with something. I'm going to put here's a 5, right? Can you all see that? It's a 5. I'm going to put that on this side here. Shoot! Well, let's see. I don't know what happened. That was absolutely ridiculous. I'll try this again. Oh no! What is going on? I know. I'm supposed to put it on this side because you're supposed to go left to right, right? So you're supposed to put the 5 on the left side. Oh no!
Gary.
What is wrong? Gideon, what is wrong?
You have to have an equal amount of weight on either side.
Also, you're snapping your
Shush, Michael.
And also, this scale, not all scales are like this, but at least with this scale, when it's perfectly even, there's like the top is perfectly
Yeah.
even, it forms an equal sign. Because there's the
Oh,
bottom line
interesting.
and because there's
Oh,
base and
so there's an
scale.
equal sign there too, isn't there? That's
Yes.
interesting.
There is.
So that means whatever's on this side has to be exactly, so what would be my problem with trying to add 5 to this side?
That side has.
Oh, I gotta add the 5 to this side. So we're gonna try it. Okay, it's gotta be quiet. Shh. Gotta be quiet. It's really hard to do, because if I do this one first, shoot, right? That's not gonna work, so I gotta do them exactly at the same time, right?
Five.
Don't mess up. Don't mess up.
Ah!
Oh.
It worked! And it's totally balanced, right? Sort of. Totally balanced, right? Okay, so we know that. Okay, now.
What?
So
Mess
now,
up.
what
Don't mess up.
is this?
It's a
It's
thing.
a thingy.
This is a
It's a
thingy.
pickle.
It's a green thingy, right? I have no idea what this equals. I have not a clue, and neither do you.
It equals the other green.
Yeah, it equals the
What
other
does it
pickle.
represent
Circle.
in an equation?
A
Circle.
A variable. Right? I don't know what it is. It's like an X or a Y or an A, B, C, right? I have no idea. All right, so I am going to put these two things down at the same time. I have no idea what's going to happen. Oh my God!
Somehow.
It's totally balanced.
Whoa.
This thingy is on this side. This 5 is on this side. What do I know about this thingy?
It's way too high.
It has to equal 5 because it's totally balanced, right? Has to equal 5. Totally right on. Now, I want to add a 4, I don't know, to this side. What happened?
Wait, don't smack it, Gary. Just put it on. I want to see if it makes it.
Oh, it would definitely make a difference. See? What? See? Always makes a difference.
Slamming it down.
Where did I lose
Putting it
5?
down
Where's my
hard.
5? Where's my 5? Here, 5. Here we go. All right. So look, I'm gonna make something a little more complicated. And for a second, I'm gonna use mental powers to keep this thing totally still while I put these on out of balance. Okay, you have to understand that. This will be, isn't that amazing? It's only because of intense mental effort that I'm able to do this.
Brain fart. Brain fart.
Well, we
Okay.
have opposite mental effort.
All right.
That makes no sense because it's
Okay.
not that way.
All right, so let's just think of what we have here. We actually, if I wrote this out, guys, as a complex, as an equation, it's sort of a complicated equation. Actually, it's not the kind of equation I would usually start off on, teaching equations, solving equations. But with a balance scale, you're actually able to do very complicated equations instantly, even in third graders. Third graders would be able to solve complicated equations using a balance scale. And so I have this mess. I have 3 x's. Technically, this is the problem I have.
You have 2 X's.
I have 3 x's, right? That's how I'd write 3 x's. 3 x's equals x plus 10. All right? All right, that's what I have. That's what I've written. 3 x's equal to x plus 10. Now, I want to simplify this. Wasn't there like another one I had? I had 2. I thought I had 2 in here.
I found it. Oh. Yeah,
You found it? Okay, thank you. You're
there you
awesome.
go.
That's what I thought. I thought I put more in there. All right. It's this table. I'm not used to this table. Stop, guys. Stop. All right, hang on. I think, is it the floor or is it me hitting the table? I guess
It has a leveler on the
All right.
camera.
So this is kind of a confusing equation the way it is. So my question is, can I simplify it? I'm going to just try. Okay, I know you guys know the answer, so just put your hands down for a second. I am going to simplify this. Is it legal for me to take one off and one off at the same time? As long as they're at the same time, right? Okay, here we go. Close your eyes. I mean, not close your, hold your breath. It worked! Still totally in balance. As long as I take the same thing off both sides, right? Now, that's still not totally simplified. I would rather simplify a little bit further. I'm going to take 1 off from each side again. Oh my God. What do I know now about this?
X equals 10.
Now, I didn't have to use any computations or anything. It was so simple. Do you see how simple that was? That was amazingly simple. So let's try something harder then, if I can do it without jiggling. Please. Ah. Okay. And then, I don't know, we'll do this. Okay, so right now, if I can do this without touching the table, I have what? 5x plus 2 is equal to 3x plus 10. I have 5x plus 2 is equal to 3x plus 10. Okay? So that's a relatively complicated equation. I would never start out a class on to people who have never done equations before, like with an equation like that. But with the scale, it's so simple, right? I could take 1 away, right? And it would simplify it. I could take another 1 away from both sides. It would simplify it. I could take another 1 away from both sides. It would simplify it. Now I have 2x plus 2 is equal to 10. What do I want? What's the problem? What's the problem with this thing being here? I want it to eventually say x equals. But I've got this plus 2.
You have to subtract it and then you would subtract it.
So I want to get rid of that. Am I right? So if I take this off, what's going to happen? Right? And it's going to go flying. So if I have to take a 2 from this side, what do I have to do this side? All right, so 10 is the same as 8 and 2, am I right?
Yeah.
It was yesterday. I remember that. Where's my 8? Please tell me I have an 8. Oh, come on. All right, 2 4s. Oh, wait, there's an 8. There's an 8. All right, so guys, this is tricky. You got to do this exactly the same time, otherwise it... Ah, phew. Okay, so now I'm going to take these 2's away and still in balance. So I have 2 x's added to each other equals 8. What do the x's equal?
4.
So let's test it. Let's see. 4 plus 4 is 8. 8 equals 8. There you go. Right? So it's pretty simple. Yes?
Isn't there another equation, like if you wanted to move all the x's to one side and you could just take them up and mash them together?
Well, in a way, that is actually what we're doing. Because think about it. If you have, I'm going to just do this one more time. 5, and then I think it was plus 2, right? And then it was equals 10, right? And then we had, what do we have over here? 3. Now I could have, so Andrea asked a really interesting question. So guys, really listen, okay? She said, remember if we wanted to combine the x's all onto one side, that's technically what we're doing here. Because this is positive 3x, right? This is positive 5x. To move these 3 x's, are you guys listening? You really need to listen, okay? To move this 3 x's over to this side, I would have to subtract them. Does that make sense? That's what I'm doing when I'm taking them away. I'm actually subtracting them from the board, right? So, but whatever I do to the one side, eventually I'm going to have a lovely little poster here by somebody that's going to say the golden rule of algebra. Whatever you do to one side, you do to the other. Right. If I don't have it yet, but when I get it, I'm going to show you guys. But if I could take all 3 of these at the same time. And that's the equivalent of saying minus 3x. I could take 3 off, and 3 off, watch. Amazing!
Okay, but like that's literally that one, but I meant like can I show guys?
Yeah, come on, show me. Oh, except the only thing is, I'm not supposed to have you on camera. Tell me what you're gonna do. So like from this, is this the one?
Okay, so like for example, 2x plus a
2x plus what?
a or whatever you want that variable to be, maybe y.
Okay.
But equals 3x plus random number.
Okay.
So then
But shouldn't we make this a number? Wouldn't that be
Yeah.
easier?
yeah.
I'll
Okay,
just make
but
that a
then,
number.
What my dad showed me is that you can actually take all those, and since you're going to be adding, I don't know, maybe it was a different case,
Well, here, let's just look at, let's just work on this one. So what I just did is I took these off the board. I actually subtracted them off the board. Look at that. I'm actually writing minus 3x. I'm gonna have to, whatever, this is the equal sign, so that's my balance. Everything's like that, so I have to subtract 3x from this side, right? So suddenly, 5x's, I have 5x's, I'm taking 3 away, I have 2x's left, right? So I have 2x plus 2 equals, these cross out, right? So equals 10. And then what I did is I took 2 away from both sides, right? Subtract 2, this is how you actually do it in algebra. And then you got 2x is equal to 8,
Yeah, and
right?
Wait.
I understand that.
Wait, I have that question.
Yeah.
Never mind.
Okay?
Right.
No, I was like.
So hold your question for now, okay? Because I have to show you guys one more thing before I let you go, okay? What if I gave you something like this? 2 parenthesis x plus 1 equals, I don't know, x plus 4. So that says, what that says is I have 2 x plus 1.
So 2x
That make sense?
plus 1 is
I have 2 x plus 1s, or
X
2x plus
equal
2. If I'd used the distributive property, I could have 2x plus 2. But really, what it's saying is I have an x plus 1, right? An x plus 1, and I have an x plus 1. That's what it's saying. I have 2 of them. Does that make sense to you?
Yeah.
Right? Equals x plus 4. So I'm going to put my x here and my 4 here. So that problem is this. So I could take, really quickly, I could just take these 2 away, and suddenly I've simplified this a lot. 1 and 1 is 2, right? So I could actually take, where's 2? I could change my 4 into 2 plus 2. I could take this and this away, and I just solved the problem. X is equal to 2, all right?
That's what I got, except what I did is instead of like, where does it be supposed to
But you probably use the distributive property.
Yeah, I used the
2x,
distributive.
2 times x is 2x, 2 times 1 is 2. 2x plus 2 is equal to x plus 4. Subtract x, right? So what I'm going to do today, for tonight, is I'm actually going to give you, what did I do with my stuff? I'm going to give you a homework assignment that is just solving equations, right? And I just want you to, it may be too hard for some of you, unless you think of the balance scale. Some of you may be able to do it without even thinking of the balance scale, but my preference is that all of you think about the balance scale while you're doing it. Just so that you're getting in your head that an equation is a scale. It always has to weigh the same on both sides. So whatever you do to one side, you have to do to the other, okay? All right, so this is the homework, and, oh wait, let's see, what did I just give you? Okay. Put that there, and that there, sorry. And then, that is your homework for tonight. Good luck.
Speaking of homework, could I have my own?
Just ask me in just a second. Remind me in just a second. All right, guys, thanks for staying a little bit late. All right, we can go.